Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today, we will look again at conditional code and how to make good use of it. Today, we're going to look again at the if command. The if command can be used to test the value of variables or the return from functions, and allow your code to become conditional. So in order to test this out, we're going to create a couple of local variables. We're going to create a string variable called result. This is going to contain the result of our processing. And our second variable is going to be a numeric variable called value. And we're going to set the value of this variable to the value 2. And in today's video, we're going to explore the most efficient way to use our if command. In order to allow us to do this kind of testing, we're going to create two functions. One called run first check and one called run second check. We will first set the value of our result string to be an empty length string. And we're going to be passing two values to this first function: the value variable and the result variable. And when this function returns to the calling routine, we're going to populate the result variable with the words first check and then whatever came back from the function. And then we will push that result variable out to our log so we can see the result of the operation. So let's now go and create the run first check function. And here is our new function, run first check, taking its two parameters: a numeric value variable currently set to the value of 2, and a string variable which is currently an empty length string. So within this function, we have an if-else endif block. We're testing two things in the if command. We're testing the output from a process function, which we have yet to create, and we are testing the value that's been passed in on the parameters to see if the value is greater than 4. If both of these are true, then we will set the value of the result variable to true and say that the value is greater than 4. If both statements are false, or if either statement is false, then we will return the value false to say that the value is less than or equal to 4. So let's create this process function. For the purposes of this video, this process function is merely a placeholder. This is to simulate a process performing a complex calculation. There is only one functional line of code in here, and it is to sleep for 1000 milliseconds. This will mean the process function will take 1 second to process. It will then return the value true. So each time this application runs, we know the process function will always return true, but it will take 1000 milliseconds to do so. So if we try running the application now to see what our result's going to be. And as expected, the first check is showing as false because the value is less than or equal to 4. We know the value we set was the value 2, so it will always return false. This is because in order to return true, both the return from the process function and the numeric value variable must both be true. This is equivalent to putting the isTrue command before each of these elements. Putting the isTrue command before each of these statements is not necessary, but I'm putting it in here just for clarity. Because in the background, what PowerBasic is actually doing is evaluating whether each of these statements is true or false. Since we're using the AND in this case, this is a Boolean test. In order for the first part of the if to return true for both of these, both of them must return true. So what we're going to do next is to determine how long it takes to run this process. So we're going to be using the ticks command. The ticks command gives you a method by which you can count clock cycles. So we're using the ticks with a quad variable. This will get the value of the clock cycle counter inside the CPU. And after our function has run, we can use the txt_n command, which will then populate into our timer variable the number of clock cycles taken between the text and the text end. So we can then amend the result to add on to it the number of clock cycles. If we run the application once more, it will run and it will tell us how many clock cycles the process actually took. So this is our base metric. This is obviously taking a large number of clock cycles, as in our process function, we are delaying the processing by a full 1000 milliseconds. So what we're going to do next is we're going to create a second function, which is going to perform a very similar check. We're going to call this second function run_second_check. It will, as before, take in two parameters: the value, which is still sitting at the value 2, and the result string variable. Once this is completed, we will close off our timer and print out the results to our log, with the words second check before it. So what are we going to do different in our second check function? So this is our second check function taking in its two parameters, just as the first check did. And the logic of the if statement appears to be exactly the same. We're doing two checks, one on the value variable and one on the process function, and returning either true or false. If we compare this to the first check function, you'll see that we have swapped the order in which these two tests are actually done. In our second run, we're testing the value first and the process second. So let's run the application once more to get both values and see what the clock count is for both of them. And there we have it. The first check is still returning 3,900 million clock cycles. However, the second function is only taking 2,262 clock cycles. So why is our second check running so fast? Is it because the order in which we're running the functions? This can be easily checked by swapping them round. So now we're going to call the second check first and the first check second. If we run the application once more, we will see the values are almost identical. The second check function is taking 1,677 clock cycles, and the first check function is still taking 3,900 million. So why is the second check function so much more efficient than the first? The reason for this is PowerBasic's use of short-circuit evaluation, where AND or the OR commands are used as Boolean operators, rather than bitwise operators. This command here will only be true if both the value variable is greater than 4 and the process function returns true. If the value is less than 4, which it is in our application, then it will return false. So there is no point in actually running the second check, because regardless of what the second check actually returns, the first check is going to be false. So if the first check is false, then there's no need to run the second. As we know, our process function is taking a full 1000 milliseconds to run. So that is the difference between the two functions. One is running both of these tests, and the second function is running only one of them. So the order you place your tests in a multiple if command, where you're testing more than one thing, is important. If you have a function which is going to take time to run, make that your last test. If we wanted both of these values to be tested, we could use brackets. Putting these brackets in the second check function would mean that both of these would have to be calculated. So let's run the application now to prove that. If we run it now, you'll see both the second and the first check are taking more or less exactly the same number of clock cycles to run. And removing the brackets and allowing PowerBasic's short circuit evaluation to run, will give us a very much smaller number of clock cycles. So in summary, what we've covered today is PowerBasic's short circuit evaluation, which will allow you to optimize your if commands to be as performant as possible. Hopefully you'll find this of use in your own applications, but that's it for today. Thank you for watching.